offset blocks. Let's take a look here. I'll just open up this assignment. It's all, yeah, all of these drawings have been on our inch template. We haven't done any isometric metric yet. Maybe next week. Let's see. The Cavalier Oblique. So a Cavalier Oblique from our textbook just means that the projection angle is going to be traditionally 45 degree. And they're usually done at full scale. And so that's what we're going to do, just full size. They fall into the same problem as the cabinet obliques. So if you have a really deep object, they're not going to look good at full scale. They would look better at a half or a three-quarter scale or something like that. But I'm just going to look real quick. Yeah. I generally think Cavalier obliques are at full scale, and so they're the ones that can become distorted at this 45-degree projection angle. But yeah, okay, good. Let's see. So yeah, that's what our image is. So I'm going to pull this up on my other screen. I think I've got my PDF here. Let's see. That block. Yeah. So I've got my PDF up that I'll be following over there. So if I'll just take a quick look here just to make sure. So I will build a glass box around this, kind of. Is that what we did? I'm trying to think if, yeah, I think we still built our glass box for even though it's a little bit of a shortened, squished little box in a 45-degree projection angle, but I will. 3 by 1.25 is how tall it is. 3 by 1.25, and then I will do it full scale this in the depth dimension. So it'll be 3 by 1.25 by 1 inch little glass box that I'll build. Yeah. And we'll start with that. Good, I like that. And yeah, I think this is kind of where we'll head here. The trickiest part of this is this elliptical. And it even looks a little choppy, even but this is a hard one to kind of get at this projection angle. So I think there's a few yeah, I think Casey showed me yesterday that used a little different technique to get that, and it worked good. So I might try a couple different techniques here to get that. I'll do the way that I've done it before, which is a little confusing, and then maybe we'll try using just a different arc function, because you have all those different arc commands, and they can be, I don't know, you can explore how to maybe get this in there. So what I end up doing when I get to this point is I kind of just like I build a boundary, like my little glass box for the entire object. I can kind of build a boundary for where this would fit, because I have the dimensions for it here, and so I can kind of build like at least a square grid of where it would fit, and that kind of helps me piece this together. So when we get there, it'll be probably the last feature I put in here. So let's jump in and start drawing this thing. So I just need to open a new inch template here. I'm going to put mine on a B-size sheet, so I'll just use my B-size template. There. And I'll model mine someone over here. Let's see. Let me build my glass box. I don't even use the isometric planes when I do this kind of a drawing technique. So we'll use more of those again next week. So we get back into first one we did this week is the one I like to do. These last two, I'm like, yeah, I just want to do them for learning experiences. And then I'm going to go back next week to like how we did the base mount and use the isometric planes. I think that's the way I typically like to draw my isometric. I do want to take over your life. Here we go. I'm kind of anti-authoritarian, so I hate doing this, but I'll do it for you. Okay, let's see. So yeah, I'll just draw the if you remember when we do these obliques, we just kind of draw the front view. We use the overall dimensions of the front view as kind of our front of our glass box. So just kind of because our projection plane is with our eyeballs right on that front view surface. So it ends up being for me just a rectangle. I want to do a rectangle. That's only three inches long by 1.25 inches tall. So I'm way out here in space. I might just move this a little closer to my origin here for no reason, but here we go. That's definitely where our front view is going to fit in. Now we're just going to do the 45-degree projections off of that. So let's do that. Let's make sure I got 45 on. Yep, I'm gonna do so 45 off of here. There it is. And it's going to be full length now. So our block is it's narrow though, huh? It's only 1 inch. So it's kind of, it is like a real cube of butter here, it seems like. So let's see that. I think what you notice is your polar tracking just doesn't like this projection angle to be able to like pull that like it would on the isometric planes. So I just draw these long and then I'll just have to project over here and trim them as well is what I'll do here. But of course I didn't draw that long enough, so I'll extend it. Then I'll trim these long or these. Yeah. Yeah, it just doesn't. Yeah, your polar tracking might not snap to those alignments like it would on the when we're at the 30-degree projection planes and we have our isometric grid. You can really use your. I use my polar tracking to my advantage to kind of track where they'll fall together. But this is a little bit more annoying, so I have to just piece it together. Like I usually on the other I can like target here and then pull back and it'll kind of pick up both of those at that projection angle. Well, it doesn't here, so I just have to pull it kind of long and then project still at the 45 degree here. Just there we go. So I just kind of overdraw for a minute and I'll put it in the 3 dimensions of it. So it'll look correct here. So there's that. And down off this straight down to where it intersects. That's the left side surface there. Trim that out. And then we get the bottom surface like this. So bottom and back. There we go. Here's our glass box. It's not totally necessary to do this. I just do this as, definitely because I'm teaching. But, if you've got the view capabilities, you just draw it in. I get it. You can do that. So this is just kind of how I show my boundary. My object has to fit in here. So it's just a kind of a tool. It kind of falls in the same way as my orthographic projections. I always just kind of did those projection planes, but I think as you get more experience, you might just jump right into and knowing that you have to keep things in alignment, right? So it's like training wheels, but I still use it at times, especially when my objects get complex and I just can't quite get things in alignment. And then a glass box always helps me solve that because I can just work on those different plane surfaces and kind of then the geometry where it hit joins kind of falls together. So if you get lost on something, then just step back and construct some construction planes for you to work with. But I am gonna start with this front view, even though it'll kind of bury stuff behind it. I do feel like these obliques are definitely driven by that surface that your eyeballs are on here. So let me just look at my object. So it's 3/4. This is the front surface I'm going to draw at real size, right to my eyeballs. That'll make this surface also just be like right perpendicular to my line of sight there too. So let's see. But this is 3/4, and then it comes over. This looks like it's what 2 inches. So it's just 3/4 up and then 2 inches over. And then this little thing is only a 1/2 inch up. So I definitely can just come in and piece together this uh, that shape of the front surface with my visible lines. It's 3/4 up this way, 0.75. Goes over 2 inches. And it's going to go down. I'll just come around the other way and hook it together because I'm going to go from here, goes all the way across the bottom, up 0.5, then back over to where it lines up with that. So those two will align because I'm in kind of orthographic alignment here, so I can project that way. So there's the front surface that I'm against here. Now I'll project away 45, right? So probably just do that on construction. I'm going to project these points just across the box, I think. It does come up here at some point to the top surface, but so I'll project this one. I don't know where it ends over there. I don't have something, but I can bring a line across here. So I'm going to pull this just long, arbitrary length. It needs to trim. It's going to somewhere that dimension will come across this way here. I can figure that out too, but this one's easier. It'll just project across to the back edge there. And this one too, I'll project across, but I don't know where to terminate it yet. We'll get that figured out now. Come across this way. Where it crosses here is this surface. That's as far as that needs to go. So this can trim that. Cell surface. Then from there it comes up and hits that one, right? And I think that one comes all the way up. I'll pull up my print and just look at it just a little bit. Yeah. So that one I came across, I'm just going to go all the way up to the top surface. This one I need to figure out how far this is. I could zoom this in just a little bit. I know it's kind of small. Let's see. Because this surface here, this is a 3/4, and then that's one to the center line. It's kind of weird. This is one to the center line of those holes. Oh yeah, so this is just the difference of 3/4 and 1 1/4. So that's a 1/2 inch. So really this is just a 1/2 inch right here. And then a 1/2 inch right here. So this is a 1/2 by 1/2 by 2, then down. Okay, so I think I can piece in the rest of the, I think I understand that. Yeah, I'll do it right here. I feel like I'm still on construction layer, but from where I left off here, this is coming up to the top surface all the way. So that's the, oh, sorry, wasn't quite trim that. There we go. That's that. I'm going to definitely trace this in with visible line work. And then this I think is going to trim too, because I'm going to come up from a half, I'm going to come over a 1/2 inch and come up to the top surface. Maybe I'll start that over here and then I'll work back this way. So definitely have some on my visible layer. I'm definitely going to trace over this. And down here too. It's my right side surface. Yep, comes up and over. I'll have to do some trimming there. So let me come back this way. It's a 1/2 inch this way, 0.5. Then it goes up to the top surface. And then this should be 0.5 as well. Yes, 0.5. Then over 2 inches. Yes, and then all the way down here. That's it. This one is 1/2 inch, 0.5. 0.5. This is 0.5 up to, and then I came across, that's what started terminating these where they stopped. Because I drew both of these long for sure, just because I didn't know where they come across. And this one still needs trim. This is still not the visible line, because what I need to do is project this one over now and then go up. And then I can project this one over now too. So I can stay on my visible line and do this here. So this one's going to come across here until it hits there, right? And then it can come back this way. And then this surface comes up. So I'm going to draw this line across, but I don't know exactly where to terminate it because it's going to meet where this one comes up. So there, actually, that is a good one. It'll project. Like I said, this surface is also kind of perpendicular to my eye line of sight, my eyeballs here. So it kind of is in relation to this. I know we've slid back on 45° and then we pick up this other surface. Since we're like totally perpendicular to this surface, we're going to be totally perpendicular to this surface. That's kind of a strange thing, but it's just because, we're not on a projection angle this way. So we just get distorted stuff across this depth mostly than anything. And the right side, this right side is as for sure. I mean, it's a distorted kind of view here too. But here's kind of a true, these are actually true lengths right here. And this is a true rectangle. So my circles, what it means is my circles will actually be circles. They won't be ellipses because I'm perpendicular to these two planes. And then I just got to finish this, right? Now if I turn off my construction lines, I should have everything. I don't really need to trim that because I never traced. That's just construction work. So if I turn that off now, this should be a completed, yeah. Cavalier Oblique. Let's do some features in it though. It's got some holes. So I'll do the easy ones first. That'll be these two that are through here. They're through. Um, so I'll lay them out on my construction layer here. Let me see what their dimensions are. Come over a half inch and then 1 inch over, at least from the left side surface, half inch and then one, and then come up from the bottom. 1 inch is this one. This is a little bit weird to see, but it is kind of hard to actually dimension something like that with our. But what I'm trying to show here is, oh yeah, it's 1 inch. If I could track this over, this is from the bottom surface up 1 inch to the holes, and then from the left surface half and one, and they're 1/4 inch holes. Okay, we do a lot of 1/4 inch holes. I feel like so because we do a lot of 3 by 4 by or 5 by whatever blocks, small parts. Let's see. So so to lay that out, maybe which one? Right here. This is a half inch. Half inch, yep. And that means this surface is a half by 2. And this one, yep, this one is a half inch. Yeah. Yeah, I think that's yes, because this is a half inch. Total is 1. I don't think it was explicitly giving here. I'm just doing a little math that, yep. 1 inch overall, for sure the top surface is a half. Yep, this is a half. So I can also just come over there to the side and say that means this is if this is 3/4 and that's 1 inch to the holes, just a 1/4 inch above that is going to be where I'm going to draw my line across for a center line. And then I'll do my vertical center lines at a half inch and 1 inch. So I'll come over here, maybe just up from here. I'm going to do this is construction work, I guess. From here up, it only needs to be up a half inch or no, 1/4 inch right here. 1/4 inch there is the center line across. Yeah. I'm going to draw that all the way across. That means it should measure from here to the base should be a 1 inch measurement. Yep, 1 inch is what's given on the drawing. So that's good. And then I've got to come over a half inch and draw down and 1 inch from there and draw down. So I'll come over here. I'll just cursor over half inch and then draw down and across at least that. I'll just draw it across the surface here. This is the center I'm looking for though for the hole. And then one more from here over. It's like an inch over from there and then down. I mean, that should make that's an inch. This is, or sorry, that's a half inch. This is 1 inch. This should be a half inch because this whole thing is 2 inches. So a little check here is that this should be a half inch. Yes, it is. So technically, these holes are centered in this surface, is what I feel like, or they're at least symmetrical in the surface. I'm going to draw those in. This one I moved over half inch. This one's an inch in between the two holes. Then I need a circle. They're 1/4 inch diameter. Sure, I'll do circle diameter here. 0.25. I'll copy that over, copy that circle. Just that by its base point, and copy it over here. And then this is pretty thick. I mean, like, I think I told you on the last one, how you would check to make sure you're not going to see that through is that you kind of need a center line there. So like I'll do this check, even though I don't think it's going to show through, and you don't have to do this, but definitely get in the habit of doing like checking yourself. This is a half inch thick and it's a pretty small hole. So if I just project, this is kind of the center line that I'm taking over here on projection, and then I'm coming across arbitrary length there. But then I'm going to take this center line over too, and where it intersects here. I'm not looking for a midpoint. I'm just looking for an intersection point there. It's kind of like close. I'm going to pull that a little long. And then I'm going to pull this one down. So this would be, this would kind of, and I can pull it down to the bottom of that surface too. But I'm just looking for this. This is the cross. This is the exit is this is entrance hole center line. This is exit hole center line. So it's good to keep track of those when you're doing these kind of drawings. I feel like in our actual 30-degree drawings, it'll show up a lot more where we'll be able to see the exits, some features of the exits from the entrance essentially. But in this, how I check that is I'm just going to copy this hole. So this will be a through hole through center, and it'll exit here. And so you can see that nothing will show through. Like the only time I'm going to keep this as a view, because we don't show hidden line work, we're not looking to do hidden work on these views. I would only keep it if it would peek through and I would see some of the exit hole through the entrance hole. That's what you gotta keep track of a little bit. This one, it's a quite a far distance apart. And it's just because it's a small hole and for the hole size, it's kind of a thick part or it has depth to it that I just am not gonna see it. So I can eliminate it, but I do these checks just to make sure so I don't get caught off guard that I should have shown some visible work there. And then, so yeah, see, I can, and then this one. So now what I'm going to do is I'm going to draw this. So now I'm ready to do this elliptical feature here. And I'm going to draw a center grid here. And then I'm going to draw kind of a boundary for it. And so all it is just this half-inch diameter circle. And it's on center here. I don't even think there's any dimensions here. That's not great. I wish this should be dimensioned. So I should redline myself to give myself that um, this is 1 inch by 1 inch. And so this is on center of 1 inch by 1 inch. You wouldn't know that though. This is underdimensioned. There's no dimensions to this hole. I've got to do this as a red line. So I should say that this is, you know, half inch and a half inch and a half inch hole. So I'm missing 2 dimensions for this really. Now that I'm working off of it. There's the midpoint of this line from here to here. That's half inch, right? Move over, there's half inch. I'm going to drag it across to this midpoint. These are my center lines for that hole, at least. That's my first start. That's what I do. Center lines. That's where I can start the center of an ellipse here. You just won't be able to pull up like an iso circle because we're not on a 30-degree plane. So then what I do is I also like will build a boundary for it. So maybe what I'm going to do is just I'm going to quickly build another construction layer. I'm just going to make a copy of this thing. Call it construction 2, and I'll keep it the same color. But what I want to do is be able to turn off my other construction layer. So I'm gonna these two center lines I'm gonna put on the other construction layer, just so I can focus on it that layer there, because I don't need this getting all busy here. I'll jump over to construction layer 2 to draw. So now I'm just focusing on this. So then what I do is I build the boundary for where that elliptical arch or elliptical arc should be in here. And so it is a half-inch diameter. So I'm not going to offset these lines because it doesn't like to offset down this axis necessarily. So I'm just going to draw these lines. I'm going to come over a 1/4 inch and build myself a little rectangular grid. It's going to be a square grid where the boundary of the ellipse lives. So let me think. I'm just going to come over here and maybe I'm just going to cursor over here. I don't think it'll let me draw that line either. So what I want to do is maybe, you know, yeah, I'm just gonna actually draw a line then. It's gonna be a 1/4 inch away, 0.25. There it is. And then I'm gonna drag this across. I'm gonna do the same thing here. I'm gonna draw over a 1/4 inch across my line. And then go back across. That ellipse has to be only that wide from kind of one quadrant to one quadrant there. And then I'm going to do the same thing here. I'm going to trace this over a 1/4 inch, 0.25, and draw it across at that projection angle, 45. I'm going to repeat that. I'm going to draw this 0.25 and across. So I've made this big old busy grid here. All I really need, I can trim this now. All I really need just to see it is just for the grid itself, I'm just looking at this. And you don't have to trim this if you don't want. I'm just going to trim it. So yours is. Yeah, mine doesn't like to track. I definitely drew those lines so that I could draw across. Like I actually drew over the top of my lines. Because it doesn't like to maybe cursor over when it's at this weird projection angle. Yeah, so I'm drawing a hard line there, so I have an endpoint to pull from or something. Because I just needed to establish a quarter inch off of center each way and a quarter inch off of center each way here. So this is just a way to do it. There's definitely different ways. This is just a way that I get my hard points, drag them across. Then I just trimmed them, the lines that I drew across because it's a little busy. But what I'm showing here is that this ellipse lives in here. It kind of goes like from here to there, and then it comes around to here and back to here and then back around. So it just kind of these are the quadrants of this ellipse here at a weird 45-degree kind of projection angle, which is just something that CAD can't just automatically draw. Or if it could, I'd have to like dig through and find out if I can change. I don't know. I'd have to do a little bit of maybe it can. Maybe it can't. I don't know. Um, but I can piece this together now. So I think one thing I think what the way that I think Casey showed me, I'm like, oh, I haven't drawn like that. Pulled down a start end and an angle. So I can try this. Let me just see how this works and see if I like, and then I'll show you my way maybe, or the way I did it is a little bit different. But start center angle or start end angle. So I know I'm on that construction layer just to see this, but this would be like if I'm just looking at what is this ellipse here. Well, this would be a start of that. Specify endpoint of arc. Well, this is the endpoint of the arc. And then it's like specify the angle of the arc. Well, it might matter on which side I actually start or stop this, but it would be a 45 is what I'm looking to do. Only I may have to start this the other way. Let me try this again. Same one. Start center. Yeah, and then this is my it's actually yeah, like this is going to be the way I would want to do this. So this is at the 45 degrees. So that would be that arc in there. It actually works really well. Like this, but you have to start on the right point. Like I could tell that when I picked the the other one first, it was gonna arc the other way. And so I came back and exited the command and started over here on this point, start here, set, end here, and then pull this angle. So that this is correct, like that. That is the arc that I want. There's the center point clear out here of that arc. But it's like a drawing an arc at a 45 degree. Yeah, that's interesting. That's a good way. I can't say I've hardly ever even used that command, but now that I like this. Yeah, yeah. For that particular one, I used my start and an angle type of like I said, these are so busy. Like like this is probably the perfect use of this particular command of an arc. But it's just like if I start here and I end here and then I pick this like snap to that projection angle, because I still have it as my main angle of snap 45. That is the correct ellipse that I want. I'm going to push that to I should do that same one here. I'll just do the one that's across from it now with that same command. I don't know which I'm going to pick this one first though. Start end and then the angle here. It looks like that one will snap that way too. So that's good. That's 45. I think it doesn't work. I'm gonna try this way. If I picked this quadrant first and then this quadrant as the end, and then I go to snap this, probably if I found the right for it, but I think it's gonna arc the other way. It's gonna be the inverse of what I kind of want at these angles that I have to snap to. So I feel like it's kind of an order of operations thing. That I there's the start, there's the end, here's my projection angle. And so I'll match these properties now, turn it into a arc. That's that one. And then we're going to come back around this way. And these are my starts and ends and my projection angle. So I'll have to figure out which one. Here we go. This one. Here's a start and here's an end. And here's a projection angle there. It's got to be on a 45. Like I'm just looking for it to be, well, which one is it? Is it this one or is it this one? I think it's this one just by the look of the arc and how it flows from quadrant to quadrant. Because remember, it's just I'm looking for the visual representation, maybe not dimensionally it's correct across its axis. They're half inch by half inch axis center lines. But yeah, so when I argue that it's not this one, yeah, it pulls it outside of the boundary for sure. And so it's going to be at a 45-degree angle. So it's either that one or it's this one. And I say the best one is the second one. Yeah. That's going to look a little bit lopsided. This one's going to look good. So I'll match those properties. And then one more arc center angle or arc start. I don't know. I think maybe it's this one first. I'll try it that one, then that one. And then I think it's the opposite way. Yep. I just can't quite get my arc to pull the right way. So start with the other point to this point, to this one, to this one, and then find that angle where it's going to be happy. Probably is going to be not that one. That one's going to be outside the boundary. So it's going to be this next one back there. And then match those properties. I'm gonna turn this off real quick. I'll go to my visible layer and turn this off, but that's why to me, it still looks like it does kind of, it looks like it's got points or whatever. I feel like there is probably some, I don't know, just it's a visual representation of that. That is a tricky thing. And I think we've got it, oh, close, but maybe is it perfect? No, maybe not. It matches what I did on mine. So it will work. Yeah, it'll work. It looks a little lumpy to me, but even my way. So I'll show you the other way that I've done this. You don't have to do this. I think that's probably the easiest way to do that. So the way I have it is I'll just briefly do a little manipulation here. I'm gonna make myself one more construction layer to show just another method because the way I did this is a little bit more like pencil. And I was, I did do some pencil drafting in my early days. So never as a profession, but just in some schooling I did for sure. Um, Let me copy this. And maybe the method that I think that is more of like a pencil method and doesn't, because if you pencil method will use a few different more construction things. So yeah, it does look like it has a point or something. Yeah, I feel like it's like a compromise a little bit. So I'm just making myself a third layer real quick. I'm gonna actually make myself a second visible layer just for a second. This is just for my video purposes mostly, and for one other method of doing this. So all I want to do is push these segments off for just a minute. I could have just pushed them to a construction layer, but I'll just make a new visible object.
It should be clicking the horizontal line, the vertical line, and then going to a 135 angle.
Yeah. So I'm using that depending on which quadrant I'm starting in, but definitely like a start here. And I think I ended up moving this one clear right there.
A little bit.
That's a 45 clear out. Yeah, probably the one I'm pulling up there. Yeah, yeah, if you could mirror maybe across here from point to point through here. Yes, that's good. So here's just another method. This is more for me than it is for you guys, construction layer 3. So what maybe somebody with lines like a protractor and some lines and doesn't have this awesome sweet command in CAD to do. They would lay out this boundary and then they're going to do this let's see here. They're going to drop, yeah, they're going to drop these center marks down. They're going to look for the center of the arc to draw is what we would look for. Whereas that defined it for us based off of its projection angle and the two endpoints in the commands in CAD. They would maybe draw from these centers down, this center down. Maybe this center up. If I just think of where I'm looking, I'm looking to establish the center mark for this arc, and this one is going to be for this arc out here. So I'll just focus on just one quadrant at a time. This would be the, so let me get rid of this one just for a minute because it's working on the other quadrant. But I'm going to draw this one down. Then I would be looking for a center mark, um, or a center place out here for an arc. So we would drop this one vertically down, and I think we drop this one in from this quadrant at the 45-degree projection angle. And I'm looking for where they actually cross, like this. And this should be the center line, I think, of arc for this to draw this. So if I was going to draw a um, circle radius, maybe if I didn't have the arc command, we might draw something like this. And I could be a little, I think I'm a little bit off here. So let me think. I think hold on with me, bear with me. I'm close here. Let me make sense out of this. Pretty sure that one down. I don't think it's this one at a 45. I don't think. That'd be clear out here. This one, yeah, not this one. This one definitely down. That's it right there. So what I'm doing, I guess if that makes sense to me, I should have thought about this quadrant yet. So it's just I'm going to pull one down, and then I'm going to pull one across at the projection angle. This is 45 degrees. I'm going to snap to that, and where that crosses my one that I dropped down, this is kind of this is the center line for this arc. And so somebody with a pencil and templates might pull something like this, and then they're going to pull that radius to that quadrant. You can see it's going to make the same kind of section of an ellipse. So this is another method if you didn't have, obviously if you didn't have a quick command, and you can identify geometry maybe a little bit. This is definitely a little more pencil-y that somebody might do this, but this would be something that could definitely identify geometry a little bit because I would do this one, and then of course all this is going to get trimmed out. And I probably could have done just an arc with a center and the two endpoints, right? Because this is all I really want of that is that. And then I would have to sit here and analyze, okay, this one here, how am I going to do that? Am I going to drop this one down and one at a 45? But it might take me a little bit of trial and error. But all I'm going to do is be dropping for every quadrant. I'm going to be dropping a center line down. I'm going to be looking for one at a projected at the projection angle where they cross. I'm going to be looking for a center line here. So yeah, this is a good one to piece together. So the next quadrant, if it was right here, I have to see here. I think some of it I can use the same. It's going to be, I have to visualize, well, this is the arc. So my center point's out here somewhere for this arc. And where is that going to be? Well, it's going to take me a minute here. I think this one's still going to come down. This one at the projection angle could be up a projection angle this way. Maybe, let me see. Projection angle up this way where it crosses. Can't say that's for sure, but I'm going to try it. Let's see here. Same center off the other one. Center here. Center here. Yeah, that's actually, it's a little easier to see there. I'm using the same. Then I would trim this out. So CAD has made our life easier as than pencil drawing would have made. But then I've got to do the same thing. I've almost have to like turn that off in my mind because what I'm creating is this. I'll match these properties here, turn these into my actual line. Probably a very similar arc. What I'm kind of interested in is to do this and then turn off the other one and just see they probably are exactly the same, likely. So here I've got a point and here I've got a point where they cross if I draw this one up where the cross is here. But I could do what you're saying too. What Sky mentioned is just mirror these across now that I've got them. Yeah, because this is the same situation I'm looking for here is a center of circle out to this radius. That's that one, right? Trim it. And then this one to this one. I've got to kind of do the same little, got to do the same little, I think I'm going to extend this one up out here somewhere because it's going to act as my, this arc here definitely has a center out here somewhere. So where is it at? Well, it's where this meets probably projecting through here. Maybe if I extend this one through, it does double duty for me. Oh yeah, isn't this great? I love this. Oh yeah, it does. This is what this is called appreciation for our ancestors and how they visualize geometry. They're pretty good. Um, they had yeah, they didn't rely on this computer program with its fanciness. They did stuff like this. Yeah, so this is it does go into you just start dropping lines. You start dropping it pretty much. Somebody probably that they were pretty mathy at the time too. So they were just like, oh, I can see easily where the center lines. The one thing that helps me track is that I just kind of visualize. Well, I can visualize where the arc should go even before I draw it, so that I know there's a center line out here where that arc is based off of. So yeah, yeah, they were better. I could argue maybe they were better with their geometry and visualizing geometry. But yeah, there's that based off of kind of a center line, projection line arc based. So let me turn off this layer and turn it off. And then I'll turn off even this the grid pattern under these. So then I'll turn on my little visible and let's see if it matches. This is voila. Let's see. Hey, I couldn't tell there was anything different. So it's the same. This is actually the exact same. Yep. We got there the same way with an easy CAD command versus somebody that has to really look for center lines and know where they're dropping. But yeah, that's good. Cool. The easy way and the hard way. And then that's it. We don't have to put any center lines on this or whatever. This is just going to become that view for us. And so that's really all I wanted to get to today. And then you can build your orthographic views and dimension them all out. Just leave that thing as your standalone drawing there, just like I've got here. And yeah, cool. That wraps up our week of this, and we'll do more of them next week, but we'll use those ISO planes and make our life a little bit easier, I think. So, like I said, I never put any views of mine in these kind of obliques for most of my mechanical drawings. However, sometimes when you go a full isometric on these two, 30-degree planes like this, sometimes it doesn't distort, but sometimes it doesn't display the features that you're trying to show. And so when we get into like Inventor, it'll drop these views really fast and easy for us. And we can manipulate the angle of the projection just a little bit to show features. So that's one thing I would do is I wouldn't necessarily try to draw it on a different projection angle. I would just like take the standard view that it would that it gives me, and then I could actually manipulate it just a little bit to change the projection angle, mostly just to show features that might get lost anyway. And well, so anyway, they get blocked that I can't see, and I'm trying to show it. So anyway, heck yeah, let's call that good. Done deal.
So, so that's
No, you gotta do the whole drawing.